a ball is thrown upward at an angle of 30 degrees to the horizontal and lands on the top edge of a building 20 meters away. The top edge is 5 meters above the throwing point. How fast was the ball thrown? Now let's interpret this. A ball is thrown at an angle of 20 degrees to the horizontal and lands on the top edge. So let's say this is what we have. There's it here. There's a level ground. There's a level ground here. And there's a building like this. And some other stands here. Some other stands here and projects a ball like this. And the ball goes and lands on the building. This is a pictorial interpretation of this. So this will help us understand what we are dealing with. So let's see this and really interpret this question. A ball is thrown upward at an angle of 30 degrees to the horizontal. So the ball was thrown at an angle of 30 degrees to the horizontal. So, and lands on the top edge of a building 20 meters away. Now this building is 20 meters away. There's a building about 20 meters away. The top edge of the building is 5 meters above the throwing point. Now this is a throwing point from the level ground. So the top edge of this building is 5 meters above the throwing point. So this is the distance along y-axis. And there's the distance along x-axis. Here we are not dealing with we are not really dealing with range. We are not dealing with some of the major terminologies we derive the formulas for, because those ones, most of them, we need mass height. But right here we're dealing with trajectory, the path, the very parabolic path is what we are dealing with. So the top edge is 5 meters above the throwing point. We've interpreted that already. How fast was the ball thrown? So we're asked to get the initial speed of throw. That's what we're asked to get. So right now we have a distance along the x-axis. This is not range, actually. This is not range, but this is the distance along the x-axis. There's a distance along the y-axis. There's the height the ball covered from this very point where it was projected from. So let's we're asked to get how fast it was thrown. We're asked to get the initial speed. That's what we're asked to get. Don't forget that this very ball was thrown along the x-axis and along the y-axis, when you resolve it into its component. So now we're going to be using trajectory. What was the formula we were given the other time? We were given this formula. The formula was derived from s equal to ut plus half at squared. That's where we derived the formula from. So distance along y-axis is equals to initial. By the time you combine them, the time is u cos theta. That's time along x-axis, u cos